Okay, we're live on YouTube and I'm going to start the webinar in the next 1 minute. Okay, I'm starting the webinar. Hello, everyone. Thanks for joining us for today's session. This session is brought to you by the team at India's premium C-level two-wheeler and CV events, Two-Wheeler Forum and Commercial Vehicle Forum, or as you're more popularly known, TWF and CVF. My name is Rohit Dewan, and I'm the event director at TWF and CVF. And for today's session, we have collaborated with 4D Simulations to bring you a session on 3D printing, additive manufacturing, and emergence of India as an EV hub. 4D Simulations is a unit of Adroitech and one of the premium channel partners for 3D printing companies like Markforged, Instech, Sayaki, and HP in India. For over the past 6 years, 4DS India has been working in additive manufacturing and has 200 plus printer installations across the country. It counts Boeing, Siemens, Shell, Minda Group, Idea Forge as some of its customers. Now, moving on to the structure of the session, we will start off first with a brief partner presentation and then have a panel discussion with few audience Q&A at the end. Other than that, we will also be running few polls during the session to keep the session interactive and invite you to share your insights. So before we start the session, just wanted to share a small ground rule. I would request you all to direct any questions that you may have to the Q&A section at the bottom of your screen. I'm asking you to do that as it will help us refer to your questions in a focused manner. You can also choose to upvote these questions. That will help us in addressing the most burning topics, the most popular topics. So please note once again, all questions to be entered in the Q&A section. So without further ado, I would like to introduce you to today's presenter, Mr. Anthony Rosengren. Anthony is working as the Markforged application engineer for ANZ in India and has over 10 years of experience in engineering and designs. This is across a range of industry, including construction and manufacturing. Before working for Markforged, he represented Formlabs in a technical capacity across APAC. And Anthony is someone who has an in-depth understanding how different advanced manufacturing technologies work and can be applied to different applications, as well as how to design for a wide range of AM technologies. So Anthony, over to you.
Thank you so much, Rohit. It's great to have the opportunity to talk today. So my name is Anthony Rosengren. I'm an applications engineer. I work directly for Markforged, and I'll tell you a little bit about Markforged in my presentation. And basically, I look after our partners in Australia, India, and New Zealand. So if we consider additive manufacturing and its applications in the EV industry, we have to consider what makes the industry unique among so many other industries. As this photo suggests, electrical conductivity plays a huge role, as well as thermal conductivity. Is it extremely important to consider these factors for the purpose of manufacturing yield and safety as automotive companies move to EV production? What I'm going to talk about today is how high-strength additive manufacturing with specialized materials will play a vital role in the emerging EV industry. So the first thing I'm going to talk about is an introduction to Markforged, who we are as a company. I'm then going to look at EV use cases for additive manufacturing. And then I'm going to focus on a few of our specialized materials. The first is our fire retardant material. The second is electrostatic discharge. The next one is copper. And then finally, I'm going to talk about some of our software, our proprietary release that we've just released last week called Blacksmith. But before we begin with those topics, I'd like to mention why companies are moving towards additive manufacturing. Conventional supply chains were on a trend towards instability even before this pandemic. This was all in response to the industry moving towards just-in-time manufacturing, where you need to give customers exactly what they need when they want it. Businesses had to adapt to this model or die. This dynamic was in play all while skilled labor was necessary to execute a manufacturing program which was in decline. So the skilled labor was in decline. And the problem is when supply chains are disrupted, you can't produce your products and revenue plummets. Additive manufacturing has given companies a way to reduce supply chain disruption by printing things on site rather than importing. And this is why Markforged has experienced such rapid growth. So basically, Markforged is an OEM that produces 3D printers, materials, and software. We've won numerous awards throughout the last few years, and as a consequence, have a lot of strategic investors, including Microsoft, Porsche, and Siemens. So we've raised over 136 million after a 82 million Series D round in 2019. In addition to this, we have the world's largest fleet of industrial 3D printers, with over 12,000 printers across the globe in 73 countries, producing 10 million plus parts per year. So Markforged can add value to your current way of doing things through a few different ways. The first is in continuous fiber reinforcement 3D printing. So basically, we produce very strong parts. And we do this in our composite series by enabling continuous carbon fiber within a matrix of material. The second way we can do this is through accessible metal 3D printing. So we developed a simple yet robust process to print metal parts that is safe and affordable for every job shop. And thirdly, through machine learning from a global fleet. So we brought cloud computing to 3D printing, enabling distributed fleets and connectivity that unlocks the potential of machine learning. So moving back to supply chains, we find that the most effective applications for additive manufacturing lie in prototypes and tools, MRO and spares, and low volume production. So as you can see here, a simplified version of the supply chain starts with manufacturing of the original part, distribution, regional hub, regional shipping, and point of need. If any of these are disrupted, you have a big problem on your hands. So we have quite a few blue chip customers across key verticals. So additive manufacturing is an extremely broad industry. So we have to be across all of these verticals. The first is in industrial automation, aerospace, military and defense, space, healthcare and medical, and finally automotive, which is why we're all here. So one of our customers in the EV industry, you may recognize just down there in the bottom right, is Tesla. So as you may know, Tesla are known for their innovation in automation in manufacturing and have experienced huge growth in recent years. Tesla uses the Markforged platform in service centers and manufacturing across the US and China. So I guess with Tesla and like any other company, typically they invest in Markforged for a couple of key applications. And once they get used to the machinery, they then are able to expand. And what we find with our other customers in the automotive industry is that they stick to a list of applications that I've highlighted here. So that is steel fixtures for bending and brazing, high-strength composite work holding fixtures for alignment, machining, and welding, aftermarket parts for vehicle repair and restoration, high-performance carbon fiber racing components, and custom steering wheels and control grips. So that's what we've seen as a pattern so far. If we have a look at what's possible or where with this further applications in 3D printing, especially in the interior of vehicles, all of these are possible for prototyping or end-use parts. So these include the interior roof, interior rear cover, sheet undercover, door inner panels, rear outer panels, side under panels, front tyre cover, HVAC ducts, the dashboard, and etc. So there's a lot of components there that can be 3D printed. So if we move on to a real example of a Markforged case, what you see here is parts from a company called Martin Weisner in the UK. And they've been printed with our flagship material, Onyx. So this company chose Markforged for obviously the strength of the parts, but also the excellent surface finish, the fact that the visual appearance of these parts is aesthetically pleasing, and for the robustness that was required for these particular applications. Here is another of our existing customers. So this customer is called Gary Rogers Motorsport. So GRM are a successful engineering and development company based in Melbourne, which focuses on the design and manufacture of race cars, as well as running successful race teams. So these guys do it all. They design, they manufacture, and they race. The team consists of 35 full-time staff between engineers, mechanics, engine builders, metal fabricators, and composite technicians. 3D printing was seen as a way to address the challenges of producing high-quality end-use parts quickly. For them, their applications include mounts, clamps, housings, and end-use parts. However, we've talked about the automotive industry in general, although there are a few unique challenges for electric cars. So depending on functionality, the materials used in electric cars require high fire resistance, high heat resistance, and conductivity. Which brings me on to my first material that I'd like to discuss, which is Onyx FR. So Onyx FR is a flame-resistant variant of our flagship material, Onyx, designed for use in applications where parts must be non-flammable. The material earned UL Blue Card and is somewhat considered V0, which is self-extinguishing, at thicknesses greater than or equal to 3 millimeters. It can be reinforced with any Markforged continuous fiber. This material is important in any application where fire hazard is a possibility, including for EV manufacture. The next material I'd like to talk about is Onyx ESD. This is one of our most recent materials. For this one, let's begin with the concept that we all know, static. As you saw in the opening slide, static can be interesting to play with, as you build it up and accidentally zap people you come into contact with. However, there are a lot of issues with this, and it can be a lot less fun in the electronics manufacturing industry. And this can be hugely expensive. That once fun zap can now destroy products and cause injury. Preventing static exposure to electronics and people is highly important. One of the worst aspects of electrostatic discharge, or this zap phenomenon, is that it can result in latent defects. A semiconductor, for example, can be damaged or weakened, but still be functional, only to fail later in the field. Manufacturers are required to use materials that are considered ESD safe to handle static charge in a controlled way. And this is the purpose of our material of Onyx ESD. You can see here an ESD part housing a PCB. So what makes Onyx ESD special is its tight surface resistance range. Surface resistance is a spectrum. On one end, there are conductive materials like copper, aluminium, and other materials that make it easy for electricity to flow. On the other end are insulative materials like wood or most plastics that hardly allow electrons to flow at all. Conductive materials make it easy for sparks to jump and cause damage. Insulative materials build up charge which can then easily jump somewhere it shouldn't and cause damage. The Goldilocks zone is the dissipative range, which allows for a controlled flow of electrons so they don't build up and jump, nor facilitate sparks through a conductive path. This is the range that we have achieved through Onyx ESD. Let's have a look at a couple of examples of applications that are a great candidate for Onyx ESD or Onyx FR. The top two examples are examples of our current customers using our technology for EV-related applications. The first is an EV company called Revo. These two images are connectors for electric vehicles. The second is a company called Russell Mineral Equipment, which is a mining equipment OEM based in Australia. What you can see here is a battery housing. It is applications like these where safety is critical and material choice must be carefully considered. And to our next EV critical material, pure copper. This material is a unique metal to 3D print and is known for its ability to conduct both heat and electricity. Unlike conventional fabrication processes, which are extremely labor intensive and expensive, Markforged copper is simple to 3D print. What you can see here is a 3D printed heat sink with a functional geometry that is impossible to machine. Some other applications for copper include welding shanks, induction coils, bus bars, and custom fittings, adapters, and EDM electrodes. So this is an excerpt from our material datasheet for copper. And some of the benefits that I would like to highlight along with this sheet are the higher conductivity than existing aluminium applications. So what we find is that a lot of companies who are producing aluminium parts simply because they're easier to machine now have the opportunity to make these same parts with copper, which has a lot better properties than aluminium for conducting heat and electricity. In terms of the composition, you can see that it is 99.8% copper minimum, and the rest is either oxygen or iron. So it's effectively pure copper. Markforged copper possesses better conductivity characteristics than alloyed copper, which has been printed on a DMLS machine. So in terms of getting this 99.8% number, that's very impressive in terms of comparing to other ways of producing copper, especially in additive manufacturing. In general, Markforged metal printing is a great fit for tooling and fixtures, prototyping, and low to mid-volume and end-use part applications. Before I pass on to the next speaker, it would be remiss of me if I didn't mention our adaptive manufacturing platform called Blacksmith. Blacksmith connects part design, production, and inspection with a powerful AI, leading to super accurate parts and verifiable data for part validation. While our material properties are critical, it is important to note that software has always been a major driver for our success and the success of our customers. And with that, I will hand the stage over. And thanks again for 4DS for having me join today.
Thanks for the presentation, Anthony. That was insightful. Now to kick off the panel discussion, I would like to introduce our expert speaker group. Our first panelist for the session is Mr. Jagdish Bagre, who has been the head of two-wheeler design at Hero Electric for the last 5 years and overall has 25 years of experience in the auto sector. He has worked extensively on improving battery technology and making it suitable for the Indian market. This includes adapting the powertrain components to new demands of CAN communicated battery packs and IoT technology to support asset tracking and fleet management. Our next speaker for the session is Mr. Rahul Shaunak, who is the Chief Operating Officer at Nexu Mobility. Rahul is a Six Sigma professional with over 16 years of experience in this auto space. In his role at Nexu, Rahul spearheads the R&D, sourcing, and production departments. He's also responsible for product development and product launches for Nexu Mobility across domestic and international markets. In the past, Rahul has spent the majority of his career with Mahindra Group, wherein most recently he was instrumental in the successful launch of the brand's electric three-wheelers as the project head and devising a global manufacturing strategy for Mahindra Automotive Export. Next, we have Mr. Anil Srivastav, who has over 3 decades of working experience with government in the Indian Administrative Service. He was formerly principal consultant and mission director at Niti Aayog, and in the past has held various senior positions in the government ministries, PSUs, and state government departments. He has also served on the board of numerous companies, including Optel Telecommunications, Air India, Airports Authority of India, to name a few. Mr. Srivastav is recognized as a prolific thought leader, speaker, and consultant on electric vehicles, mobility, and transportation, and we are honored to have him on board today. Our next panelist is someone you have already been introduced to, Mr. Anthony Rosengren, who is the application engineer for ANZ in India at Markforged. Our final panelist for the day is Mr. Inderveer Singh, founder CEO at Evage Ventures. Inderveer's entrepreneurial journey started in 2014 that led to the conception of Evage and building his first product, a four-wheeler, one-ton commercial vehicle. He comes with around 10 years of extensive automotive experience, spanning R&D, plant management, business, and sales. Finally, I would like to welcome our moderator for the session, Mr. Som Kapoor, who is the Automotive Future of Mobility lead at EY. Som started his career in the Indian automobile sector, working across the sales and marketing functions, and since then, consulting has been his way of life. He is a specialist who has been working with automotive C-suits for the past 2 decades and brings with him rich insights on the changing business scenarios and the future of mobility and retail, both from an Indian and a global perspective. Over to you, Som.
Thank you. Thanks, Rohit. Good afternoon, everybody. Hope everyone's doing, hope everyone's nice and safe, whatever part of the world you may be in today. Thank you, all the panelists. Thank you. I'll say a round of thanks from all of us to the people who are listening in and hearing us out up front. But let me get this rolling. Actually, Mr. Srivastav, I'm going to put you on guard up front. Since this is about how can 3D and additive manufacturing help on the EV side, your perspective, will this help in a faster rollout? How can really 3D and additive manufacturing specifically work towards the electric vehicle trend that's emerging in India right now? Mr. Srivastav, I think you're on mute.
So firstly, a very good morning to everybody and my greetings to all the participants and all those who are listening to this webinar and the discussion. Well, coming to your question, I would not be in a position to say specifics as to where the 3D and all this technology could be used in the EV. That's more of a technical understanding and a technical answer. But as I look at it, there are a few things which I would like the attention of the audience and the participants and my fellow distinguished panelists also to understand that is that electric vehicle or this mobility solution for the first time provides an opportunity for India to move forward in the automobile sector, where in the internal combustion domain, we did not design, develop, and put forward a product. The products have been designed and developed not in India but in other countries, although we then subsequently we started manufacturing them, or I started adding value partially or significantly maybe to some products. But then this electric vehicle transformation provides opportunity for the country to move forward in terms of the design and the development of a product which is suitable for the Indian needs. Now, India is different from the in terms of the automobile from the world, and very rightly the government has put its focus on the two-wheeler, three-wheeler, and the public transport aspects of the mobility while deciding the direct fiscal incentives for the electric vehicles. Why is it so? Because more than 80%, rather 83% of our automobile manufacturing in terms of the numbers are two-wheelers and three-wheelers. India moves differently. We have an average trip size of around 5 kilometers, and more than 50% of our trips, even today, are by the non-motorized means of transport. So look at the Indian mobility, look at the Indian condition, and that is where probably your technologies about the this 3D and all this designing and all, they come into the picture. And that is where we need to put our focus, and we need to appreciate and understand as to what this country needs. This country has the size, this country has the scale, this country is the fastest growing economy of the world. This country has the youngest population mix in the world, a very large number of people who can contribute to the economic development. And when you look at it in that perspective, the role of your technologies and designing and applying the 3Ds and whatever is going to be discussed in terms of the technology is becomes much more relevant in the Indian context, and we cannot ignore these facts about the uniqueness of the country, about the Indian market. I would suggest that your technologies and your initiatives provide a very good opportunity, rather the best of the opportunities for Indian companies, Indian manufacturers to reach to a position which I call very often call as a pole position or the leadership position globally, making use of the local size and the scale, making use of the latest cutting edge technologies, and moving forward to take on a position where we are adding value in internally, indigenously, and supplying to the globe. This is what would be my take. I'm not going into the technology or the technical aspects of it, but I'm trying to give a perspective which should not be ignored by the industry or even by the technology people also.
Thank you, Mr. Srivastav. I mean, and that was a great context that you set up also. I'm going to put Mr. Bagre on the spot over here because he heads the design of the upcoming highly competitive electric two-wheeler marketplace in India. We hear the largest factory for electric two-wheelers will be built in India soon by a competitor. They themselves are buying companies which are doing electric two-wheeler design. So, Mr. Bagre, from that technical aspect, do you think your time to market will reduce if you use if you use emerging technologies like additive manufacturing or some of the examples that were given by Anthony about 15-20 minutes ago? So 3D seems to be a buzzword. It's one of the, and it's been a buzzword for a few years now. So how would 3D and additive manufacturing help specifically for electric two-wheeler design to a certain extent? You're on mute, sir. Mr. Bagre, you're on mute.
Yeah. Now, I would like to put this perspective. Yes, certainly, very much because of 3-4 reasons. First, today EV industry is highly product variant mix. So there are many models, many battery sizes, and many types of attachments and accessorization. Because EV meets very specific needs also and a general need also. But if you look at the time to market, which is the most critical factor, and the time to do the certification, the time to do the piloting, the prototyping, testing, this can be certainly reduced. Today, there are a lot of battery manufacturers available, startups coming up with different battery pack sizes, swappable batteries. All these needs different type of accommodation in the two-wheeler, three-wheeler. So they need a different altogether battery compartments. They need different fitments, accessorization in terms of delivery boxing, in terms of containerization of goods. So all these needs are quite different, and they need a rapid prototyping, sometimes a cold box, sometimes a hot box. So all this is there. Then also we are at the it is not like IC engine. We are looking at a very customer satisfaction and also a delight. When we mean delight, the product has to be very aesthetic. It has to be very eye catcher. So in that perspective, there are a lot of styling improvements which are being done in terms of panels, in terms of lighting, in terms of even the accessory location, mobile charging. All those things are fast changing and the requirements, customer requirements are also fast changing, and we have to be ahead of this competition. So in terms of global and in terms of local, so to put that perspective and to meet the customer expectation, we need to design very fast, we need to do prototyping, testing, certification. So if we go by a conventional method of doing things, the time to launch in the market would be 3 years. But now we have to crush the time to 1 year. So I believe that this way of doing 3D printing, and even the process in advance, we can figure out manufacturing defects which are likely to come. Then secondly, we can also focus on the various tools, assembly fixtures which we need to do at our plant level. So this is going to certainly help in visualization, streamlining. So I recollect my just 10 years before, where a part was being made, then it was supplied to various teams to build fixtures and those things. Now as soon as the concept is ready, the part would be given to all process and the assembly manufacturing line. So the time gets reduced. That is number one. Second, also is a very enhanced function which I could understand today, is the battery life, which is most important. And to meet that battery life challenge for the Indian condition, where the temperature is high, the moisture content is high in the geographic conditions. So all this, whatever the thermal conductive materials are getting put, so it will carry away the heat very fast from the BMS and also from the cells. So this is a great thing which we look forward now.
Thank you, Mr. Bagre. That was quite insightful. Rahul, I'm gonna jump to you. I mean, can I get a practical example from your or Nexur's perspective in terms of, how did you go about with prototyping and maybe speed to market or cost, whichever way you want to take it on?
Yeah, I'll take that question. Som, thanks for that. I'll take one example. Very recently, we have launched the new series of our super cycles, electric super cycles. And in the course of the development, I'll take the example of rapid prototyping and how did we use the technology put to use for the customer, and how it's actually helped us to speed up the things, speed up the development. So we actually did a lot of front loading, and our objectives were very clear, that we are designing and developing the products made in India, developed in India, and for the Indian customers, and eventually for the global customers. So understanding of the need was a prime thing for us, and putting the technology to use is direct relation of the customer need. So building robust customer base, building robust product for which has a customer focus is something we've been following. Now, talking about the rapid prototyping, we actually used it for parts like battery, IoT integration, chassis, frame we call it, and the way we did it, we actually followed the gateway methodology of product development and tried to use the rapid prototyping wherever possible. The ultimate aim is to give the product to the customer from day one, when the start of production is there, with zero defect. So actually, if I see how rapid prototyping is helping ultimately the customer, is that the customer gets zero defect product from day one, and that's the methodology we have been following.
Yeah, well, congratulations on trying to get to zero defect from day one. Inder, you're a founder of a venture as well. From a startup perspective, to a certain extent, will 3D printing, additive manufacturing actually be a help you compete versus with the bigger boys to a certain extent in the marketplace? Any thoughts around that?
Yeah, thanks, Om. I'll take the answer to your question. Yes, if you look at it, as a startup, we don't carry the baggage which is, um, traditional companies have, sacrosanct with them. So that allows us a lot of creativity in our design. And when we do this creative works, sometimes the processes don't support that kind of creative designs, right? And that's where the gap can be bridged using 3D printing, additive manufacturing, and these advanced tools. So that's where the benefit comes in. And I would just like to take a step back on this as well, and just put things into perspective. This is a new industry as such, or a product type, and they move in technology convergences, and those convergences are happening now for us in the automotive industry in terms of what additive manufacturing offers, right? First, we are moving to AI based designs. Generative design is becoming the inward, and at least aerospace companies are moving towards generative design now. What that does is it solves the problem of creating lightweight, stronger materials and designs. But then it also creates another problem: how to manufacture them economically. So that gap is being filled by 3D printing or additive manufacturing, so as we call. Of course, it's just a sunrise industry, I would say. There are a lot of challenges in terms of reliability, repeatability, post processing, um, and other things. But for a startup like us, we had and we have a few patents around this as well. While for we have been able to. In fact, we are the first company in Asia who would be building vehicles out of a micro factory, in part aided by innovative designs, generative designs. Complemented by some or the other form of 3D printing during our processes, process layouts, and new materials that we use. So all this helped us, through additive manufacturing.
Okay. Thanks, Inder. This leads me, you were going in the direction towards lightweighting. Anthony, since you're your presentation was a lot more technical as well, especially from an EV perspective, because, lightweighting directly impacts a big problem of range anxiety, because you tend to drive it longer as well. If you could just give us I would want you to touch on two things. I would want you to touch on lightweighting, and I'd want you to touch about the cost arbitrage that 3D designing or additive manufacturing may probably give smaller startups versus big OEMs which are already in this business. Would that be a fair question for me to ask you right now?
Yeah, sure, no worries. So yeah, with lightweighting, that's an obvious benefit. With 3D printing, complexity is free. So if you design something, with software that can automatically take away material where it's not needed, then you can print that basically. So that is a massive benefit for when you need to increase aerodynamics and to lightweight parts. If you are trying to do the same process via machining and you're trying to lightweight part, that can introduce complexity, which can be prohibitive, and you cannot reproduce the part anymore. So, 3D printing is very valuable for lightweighting. In terms of, I guess, like the cost journey for startups, I work with a few companies, both here in Australia and in India, who have chosen to start off with 3D printing to produce end-use parts and tooling. The reason why is if you have one specific part that you need to be made and you want to injection mold that part, that can cost $10,000 US. If you make a mistake in that injection mold, then that's $10,000 down the drain. So what 3D printing enables is the same strength of part, but for the material cost and the capital cost of the equipment. However, you're not investing in one design, one mold, you're investing in a process, and you can change that design very, very quickly. So that's why it tends to be a very good solution for startups as well as established companies. So startups tend to produce end-use parts, established companies tend to produce the tooling associated with mass production. Does that answer your question?
Yes, it does. It does, and especially the part on the cost side of it, because that's what I've been hearing as well. that there could be a definite cost arbitrage improvement that could happen with 3D and additive manufacturing, which could help startups. So that's what the question was for. I actually have a very basic question here and it's from somebody who's listening on with us, Sandeep Garg. Is 3D printing possible for all kinds of material? Let me start with Mr. Bagre. Mr. Bagre, in your experience, what is the kind of possibilities for 3D printing? What kind of materials?
Yeah, that there are three kinds of materials. First is we normally classify into one is steel and plastics. So in plastics, definitely in India, we have seen many examples, and there are ongoing people who have done a lot of work for last 10 years. 3D printing is being extensively used in automotive industry for plastics. On steel, yes, it is a somewhat nascent stage, but it is growing. So in terms of lightweighting, where we need very lightweight aluminum composite structures, where the industry feels it is very, they don't have the enough capability, the storage, the pipeline, SCM to have a lot of material, but still lightweighting is required in below seat structures for two-wheeler, three-wheeler. So I believe that lot of lightweighting can be done. And for a battery operated vehicle, even a 5% weight reduction would mean, let's say, I don't know, even 10% or 15% range increase. So there are huge advantages in lightweighting for a EV, because everything more so is weight dependent, and that lightweighting and strength increase go hand in hand, and durability. So what customer is at the end of the day is looking as is value for money. So higher total cost of ownership is lowered, and that is how 3D printing would change the scenario for the EV industry in terms of lightweighting.
Okay. No, that's very good. Mr. Srivastav, I'm going to come back to you. During your interactions with the government or while you were at the government, is the government thinking, is there any thought around, helping companies which are getting into with additive manufacturing or 3D printing? Can they expect something coming out of the government?
I really don't know. But when you say, can they expect something from the government? What is it that they should be
Can they
expecting?
expect a can they expect a tax break? Can they expect some kind of land allocation for startup companies which are getting into 3D printing or any kind of additive manufacturing? Can they get some kind of a technology transfer help from companies overseas? Is there any thought around any of these topics?
3D printing is not going to be exclusive for the EVs. 3D printing, then it is a 3D printing for the entire manufacturing or uh,
Mhm.
for this thing. It's not specific that for the electric vehicle only this 3D printing is there.
Okay.
So that way, if the 3D industry or this industry is expecting any kind of a government incentive, direct or indirect, or the fiscal or non-fiscal incentives,
Mhm.
then it will be not be clubbed under the EV. As I look at it, it will be under the some advanced application of the technology or the cutting edge technology, and under those heads. Because once you have a 3D printing, then the 3D printing is for the all set of manufacturing process or the other industries as well. Secondly, if there is anything specific to India, and if a 3D industry is requiring some kind of an assistance for that, that probably should be brought into the notice of the government, and then probably the respective ministries, whether it is the science and technology or information technology, or maybe the industries department, that is the DPIIT, they can have a look at it and can decide about it as to this industry requires something which is very specific to Indian conditions, because 3D varies from country to country depending upon the local climate, local environment, and local conditions of that country.
Okay. So what you're saying is that there should be a industry lobby to take this discussion forward with the government.
Yes, exactly. It should be that the 3D industry in totality, as you said, should be trying to take it forward here.
Okay. Thank you. Maybe, Mr. Bagre, that is something for you to figure out if there is a industry association and how you can participate and get a few people together over there.
Yes, surely, because there we can look in two aspects. One is the advantage of lightweighting in terms of the overall automotive industry, where the range extension happens, the range is anxiety, or the KMPC, the kilometers per charge improves. Or we can look the other way, is the lightweighting of the unit itself, and some incentivization can be taken forward. Yeah.
Okay. Anthony, I'm going to come back to you because there's another technical question. It's from Vijay Kumar, and I really like the question because it's very valid for India. How can we improve thermal management using 3D printing? Would you have any thoughts around that? Because that could really help us get some advantages here.
Sure. So the way to get rid of heat is basically to run fluid over the hot thing. So that fluid could be air or it could be liquid. So one way through our composite system to get rid of heat is to simply design ducts that direct air over the hot surface, and that will help to remove some of that heat. The other way, or the other way, but in a different method, is to have internal cooling channels. So if you have a hot object, if you have a hole through that is conformal, you can run fluid through that and then cool down that object. So what 3D printing enables is conformal cooling. So it enables you to make these strange shaped holes through the object and run liquid through them. And if you try to do that with traditional methods, it's very, very difficult to achieve. You can achieve it by drilling in multiple holes and then plugging them, but then you have the flow, and the laminar flow is disrupted. So you're able to ensure that you have the smooth flow of liquid so that you have very effective cooling.
Okay, thanks. Rahul, when you spoke about prototyping and all that, there's a question from somebody in the group here. It just says, is there any surface finishing requirement for 3D printed parts? Would you have any knowledge on that? Is surface printing really required, or is it already incorporated in the part? And he's given an example of heat sink.
Surface finish do comes in picture. First of all, I'll take a step back. 3D printing is not a new concept in automotive industry. It's been there for a long time in IC vehicles. So we know what kind of, or rather, I will say the industry know what kind of application is directly relative in 3D printing, and what kind of application will be exploratory in EV application. So surface finish do matter to answer your question, but what is the objective of 3D printing? Whether it is the lightweighting, whether it is the reduction of the tooling cost because of not going for hardcore tooling, that is the objective. The objective has to be very clear why we are going for 3D printing. So that's something we should always look for.
Okay. Actually, this is a good time. Rahul, do you want to, Rohit, so do you want to run a quick poll on a few of the topics that you thought about in terms of getting some participant feedback? Guys, can you just, if you guys see the poll, can you just try and answer that? Which of the two? I would go with.
So in the meantime, maybe we can continue with the discussion while people are answering it in the.
I actually answered the poll, so.
Oh, okay. Apologies.
No worries. For the manufacturing. I have a very different question, and Mr. Srivastava, I'll start with you. Is it fair to say that the EV industry shall be the torchbearer for advanced automated manufacturing processes? Do you think EV industry will lead this charge?
EV industry could be the torch bearer for the advanced application of technologies in the manufacturing processes. to the extent that it is in the automobile sector and limited to that. That is where probably you are correct. But yes, the number of startups and the number of new initiatives which are getting into the EV industry are far more than leaving aside the IT or the coding, that industry, software industry, if we leave aside, then in any manufacturing industry, this is happening for the first time in India, that this kind of a disruption is taking place because of the startups and the new entrants. And that is not only restricting to the manufacturing, but entire the mobility paradigm, the movement of the goods and the movement of the people from point A to B. And in that context, your question is very right, and I mean, it's a very positive thing. And I would like to add a positive note to it is that yes, EV industry can lead the charge, but provided we do not lose the momentum and the transition which is taking place, and we just keep pace with it, we keep adopting it, and do not let the opportunities which we missed in terms of the solar panel manufacturing or the smartphone manufacturing. So this is a crucial time for the Indian industry and the players, those who are in the field. And I urge upon them that they should make the best use of it. And yes, you are right. EV industry can lead the path.
We have two players here. I'm going to go to them, Inder and Rahul. I'll start with Inder. What's your take on startups in a certain extent taking on conventional industry players? Do you think automation? Do you think 3D? Do you think technologies like this can help you come at parity? Or
Yes.
any other specific technology you think that could help
Yeah,
you?
I'm coming to that. So we need to understand. Traditionally, the automotive industry works on the principle you invest few millions of dollars, set up a capacity of millions of vehicles, and then hope to sell these vehicles at scale, hoping to bring the unit economics into play, and then make money out of it, right? So that is the traditional model of any automotive player, but things are changing. There is a change in consumer behavior we see. We are seeing people, and I'm talking in the future because we are startups. We need to traditionally solve problems of the future, right? And we see people are moving away from ownership of vehicles. There's a requirement for high degree of customization. I would love to have my own seat position wherever, however I want it in any vehicle asset. Well, this is just to name a few, right? And these things are changing, right? And the designs are easy to change. The tough part is manufacturing that needs to change to meet up to the demands. And that is where advanced technologies, 3D printing, of course, would be one of the most important technologies because it helps in customization. For ourselves as a startup, we are trying to build these vehicles in a small micro factory, which is a big difference from a traditional way of doing things, right? We are trying to eliminate a lot of processes, paint shop, for example. We're trying to eliminate the press shop as an example, so that we can make these small modular, sustainable manufacturing practices and decentralize the manufacturing process across the geographies. And we'll see that every urban environment will require its own customized set of vehicles. Uh, Taking India, Bangalore and Delhi may require different vehicle categories to make the city function properly. And if you have to make these highly customizable vehicles profitable in small to medium scale manufacturing, that's where the startups come in, right? That's the gap they will fill. And we as EVH are trying to do similar things. And 3D printing is going to help us create these kind of customizations on the go. Like at EVH, we are trying to build something like the IKEA of the automotive world. You come in, customize your vehicle, and you go with the vehicle next day morning, right? And that's where 3D printing actually comes to its own. And then there are challenges, as I always say, the cost arbitrage, which we discussed earlier, but the customization is going to be there. We have to have small, sustainable manufacturing setups, decentralized manufacturing, agile supply chains. All these problems have solution through 3D printing and other advanced technologies, different materials. Industry 4.0 will play a big role in this, right? So that's my take on these future advanced technologies.
Rahul, from your perspective?
Uh, I will start with the saying that we always look at the before that you asked that will the startups be the torchbearer of implementing any technology such as 3D printing? Yes, we do that. We do that in day-to-day vehicle development life cycles. We do that every day. We try to solve the problems by adopting the technology. So the baseline here is that what problem we are solving. One problem we are solving is that addressing the customer need of mobility. Whether it is whether the 3D printing is actually reducing the vehicle cost, whether it is lightweighting, whether it is the battery cooling technology or packaging any IoT or battery or I will say power electronic item in a way that customer has the advantage. Yes, we do that in our day-to-day operations. I largely agree with Mr. Indavir that we are actually pivoting away from the traditional model of investing heavily in the manufacturing and then offering something which is a capex heavy solution to the customer in a way. Customization being just one aspect given to the customer. We've been I will come back to that again, that putting the technology to use is always the thinking behind in our culture or in our company's blueprint.
Thanks, Rahul. Rohit, this is an exciting thing between EV and say, traditional players. What did our survey say? Do you have results out of that? Oh, there you go. So it's well 60-40. It hasn't really swung one way. You have a little advantage. I think there are more people from the EV startup system participating today, maybe out of the 100 odd people here. But yeah, okay. So it's fairly competitive, is what I'd say. Mr. Bagre, I'm going to come to you. You're part of the traditional ecosystem to a certain extent. Would something like a paint shop get eliminated?
Yes. The answer is yes, because traditionally the manufacturing has been very where you do some small prototype and then take to a mass scale, as what Mr. Already Indervit has told about. So investing is not the correct approach as of date, because you need to do lot of product mix, you need to do lot of variation, and you still need to meet the customer expectation as fast as possible. So earlier these granule now I mean painting is there, but traditionally, but if you look at now, the same process can be achieved by adding granules, granules into the plastics, and the same surface finish can be obtained. So today, what we see happened in the like laser cutting of sheet metal was something new 10 years back. But today, for all prototyping, all piloting, everybody uses laser cutting. It is the norm of today. So 3D printing will become definitely the norm of today, and then also including like uh, color in the plastics, self colorant granules.
Okay, nice. So you're basically gonna, asset light seems to be the model going ahead to a certain degree.
Yeah, because now if you look at the traditional earlier process, even people relied on FRP and other things. But look at the strength and the surface finish. Now today, what we this 3D printing offers is a much complicated structures, much better surface finish, much strength, and even the flexural strength, and the advantage also in the battery cooling, where the entire TCO of the customer depends upon how the battery is cooled and how the life of the battery is extended. So yes, definitely there is a great way forward there.
Anthony, back to you. We're talking about lightweighting, etc. how does that impact the fatigue strength of 3D printed parts?
So if you when in the process of lightweighting, there's a few design considerations to take into account. Obviously, you're trying to make the part lighter, but you also need to take into account where the forces are acting and where the fatigue is going to be. So if you design with good software and can test the geometry, then you know, lightweighting the part should not affect the fatigue strength at all. It depends on the designer and the engineering behind it.
Okay, that's great. Rahul, Shonak, back to you. Since you're part of this whole ecosystem now, do you think 3D printing technology could ever take on or replace traditional mass manufacturing? Is there something like that for the future?
For smaller scale, prima facie in smaller scale, yes, 3D printing is a solution in many ways. If the numbers are small, 3D printing makes sense as on today also. But for mass manufacturing, if we talk about numbers in hundreds, thousands, case to case basis, but largely the tooling makes more sense than 3D printing for a larger scale.
So, Inderveer, give me an example of a factory of the future for an EV.
Yeah, so the factory of the future, at least what we are trying to do is, we have eliminated certain core processes. We have eliminated the paint shop, the press shop, the welding line, which are traditionally,
Yeah.
in a traditional car plant, it would take 8 hours of your process time on the vehicle off. It would take few kilometers or few 40 to 50 stations on the assembly line off the thing. So that's our approach to the factory of the future. We'll have interconnected machines doing real-time analysis. We are now in the process of setting up our manufacturing plant. We are moved into AI-based visual systems for inspection rather than move into fixtures and all. So these are small things that are changing. AI will play a big part. Inspection will be automated. The factory of the future would have a higher production per square meter with lesser people on. The operators would be highly skilled and limited operators, but highly skilled operators. And it would be sort of a co-working space. Currently, you have either robots or people working. You can't have both of them working, but the future would be that machine maintenance will be taken care by AI-based systems. A lot of AR and VR activities would be integrated into your manufacturing setup. Traditionally, we have the work instructions, process instructions for the operators, which were days gone by. 10 years back, they used to be on a notice board, moved on to screens, and now they would be on AR VR based devices. And the manufacturing would have a digital twin kind of a concept where you have drawings and the production all on the cloud. And so that would integrate the customized orders which are required by the customers, put it on the cloud, and then customize it. And if 3D printing gets viable at a mid scale, small to mid scale, also in terms of the cost arbitrage, we could potentially have a customer design his or own product, and then 3D printer will take the command from the showroom and print it out and send it over. But this may be a decade away. I don't know. It's not going to happen anytime really soon. But that's how the factory of the future would look like.
I'm going to put you on the spot. Define anytime soon.
Could be a decade or more.
Oh wow! So that's a fair distance away. Anthony, do you agree to that? A decade away?
So in terms of the factory of the future, that comment, I guess we're talking about Industry 4.0, and Mark Forge's position is that we produce machines and materials that are useful now. They're not necessarily for prototypes. These are machines that are as reliable as CNC machines. However, they're not going to print everything. As I said, printing the tooling, some prototypes, all that sort of stuff is some of the applications. So you have to choose your applications wisely. So I guess it's not going to be like a black and white. Suddenly you have a factory of the future. It's going to be a slow process, you know, and company by company, and depending on the labor costs in various countries as well. That's going to influence how this factory develops.
Also, Som, if I can add one more point over here. I always believe that the torchbearer for mass adoption of 3D printing is going to be the generative design aspect, which I guess Anthony would agree to as well. With generative design, it gives us the capability to go ultra lightweight, and the processes that are going to be needed to make these generative design components are going to be only viable via 3D printing at the moment, right? And that's the area where we'll see this kind of merging together in terms of mass utilization of 3D printing, at least from the automotive structures point of view. I just heard about the thermal printing thing. I mean, that's a great opportunity, but in terms of mass utilization, I guess it's when you marry generative design with 3D printing is where you get the best effects.
Okay, thanks, Inder. That was interesting. Actually, there's a question from Ashwin Pawar, which I really wanted to pick up. Can we directly manufacture heat-resistant battery fixtures? And what is the ultimate strength we achieve with only ESD material? So, it's an interesting point because that seems to be a big bottleneck. Mr. Bagre, would you have any thoughts around that? Mr. Bagre, you're on mute.
Yeah. So in terms of, there are various types of cell forms. Today, if you are looking at a prismatic or a cylindrical, but the heat which is going around today is an empty airspace. So the conductance is quite, and convection is quite low, because at one hand, the battery is IP67, you need fully waterproof battery and all this. So at the other hand, the same inside electronics is there, cells are there, the heat has to be conducted to the surface as soon as possible. And
Mr. Bagre, I think you've gone on mute. You've gone on mute.
So the high conductive materials which will carry away the heat from the cell core, and where the BMS is there and where the heat is generating because of dissipation of the cell balancing which is happening. So all that heat should be quickly taken out to the surface. And also the second target is water resistance IP67 batteries. So both go hand in hand, and then it will be as fast as possible to implement these kind of things, and very cost effective in the overall life cycle of the battery.
Okay, that sounds exciting. Actually, I just wanted to set up some time for people to ask questions also. If there's anybody Rohit, do you want to pick up some of the questions and go for it?
Yeah, so we'll start with the Q&A section. I'll ask a few questions, and then maybe you can scan the Q&A section and then meet them and ask the rest. One of the questions that has really come up is that in terms of, be it any of these up and coming technologies or any latest technologies, India is a unique market. So you need to adapt it to the Indian local market, the Indian EV market. So that technology essentially needs to be flexible for adoption in India. Okay, so I want first Anthony from Markforged to sort of answer this, because he's working with Indian clients. Then maybe maybe Inderveer, if you want to take this, and then finally, so maybe because you work with various automotive companies, you can sum that up. Yeah, Anthony.
Sure. So in my experience, the reason why we see adoption of additive manufacturing in India is very different to why it's been adopted in Australia. In Australia, labor costs are extremely high. So often we compare one part to another part, and it's cheaper to 3D print than it is to make the traditional way, which is involving a lot of labor costs. In India, there's a variety of reasons why people would want to invest in additive manufacturing. One, if the labor cost can be one, but it's less common. One part mainly is their supply chain. Often companies in India will get their parts from a lot of different sources. And if there are disruptions to that supply chain, which commonly happens, that's when revenue is lost. So if you can provide resilience to that supply chain, then that impacts your bottom line. So that's one of the reasons. Two is what I find is that in terms of skilled labor, and just like globally, in India, what I understand is that machinist talent is reducing and employee retention is also reducing. So, if you're able to have that talent as CAD design skills and not these traditional skills, which are very hard to come by, then you're making it a more pleasant environment for people to work, and you're retaining employees much more easily. So that's a couple of reasons why we see adoption in India as opposed to Australia or America.
Yeah, taking things forward from what Anthony said, I believe the reason this question stems up is primarily from the cost arbitrage factor, because as a consumer market, India is really sensitive to the pricing of products, and that's how India generally is, right? And thus far, it's expensive to invest in additive manufacturing setups and also produce parts. So that's the reason this whole idea, whether it will be viable in India, whether it will meet the requirements of the Indian consumers. As far as the technology is concerned, I believe there is no question about whether it's robust, it's reliable. I mean, there's not a doubt about that. And I believe it'll be a process of how it gets integrated into mainstream production. And it would start with tooling, fixture and design. Tooling repair is already being used in a large way. So these are the areas which would start to integrate it into mainstream production, and then eventually, we as designers of products have to be mature enough to understand the advantages that we can leverage out of these new technologies. So when we marry a couple of factors, only that's when a new technology actually picks up. So technically, yes, it's a good technology ready for India. Cost arbitrage is still a question mark. But when we add up into the smaller benefits and a slow integration into the mainstream processes, I guess that's how 3D printing is going to take up in India.
I mean, Rohit, since you asked me the question, what I see from multiple OEMs and startups that I see, we're great at blueprint and beyond, right? We're good in that initial manufacturing perspective, but where I think where the challenge lies is before that. And with 3D printing, that is where I think we'll be able to build on an advantage. What Mr. Srivastav said, right? It's probably already a level playing field if we get involved, if we get upfront and we manage that part of the value chain, because that's a very, very, uh, it's a very high value part of the value chain actually, because that's where a lot of the, I think Rahul spoke about patents and things like that are existing in that part of the value chain. And if we can get that part of the value chain right now, it will really help us take it beyond beyond the blueprinting also, because for us it's new. For us, beyond blueprinting is something we have manufacturing under control to a certain extent, but we probably don't have the earlier part of the blueprinting exercise under control. And that's where I think a lot of the innovation that is happening, that is starting to happen in EVs, can actually help India to a certain extent.
I would like to add one more point here. We spoke about that so the OEM side, the capability is there. The OEMs are the torch bearers, and the technology is well put to use. The second part is that the technology is offered by the supplier fraternity. Uh, uh, the way the automotive, rather I will say the EV side of the supplier fraternity is shaping up in India, it needs one bit of support so that they can offer additive manufacturing or 3D printing solutions, like these are just two examples, there are multiple of examples, can support OEMs cost in a cost effective manner. So effectively, the TCO will eventually come once the costs of the offered parts from the suppliers are coming down. So when we mentioned, I think Mr. Anil Srivastava asked that where are the areas of improvement of bringing these technologies to the mainstream. One area we see is that uh, assisting the supplier fraternity in a way will eventually help adopting these technology and bringing these technologies to the mainstream with the objective that the price passed on to the customers is really less. We have opened the dialogue with DPIT and DHI, and happy to share more information on that front.
Okay, that's exciting to know. Uh, but Rohit, back to you if you want to pick up a couple of
Sure.
questions from.
I think while Rahul touched upon this earlier, I don't know if Anthony got a chance to share his insights. That in terms of even when you went through your presentation, you spoke about how this 3D printing is currently being used for prototype development, production of individual quality components in small quantities. Do you expect it to move into serial production anytime soon, or is that some time away? Or I mean, what are your thoughts on that?
So that was directed at me.
Yeah.
I guess like additive manufacturing is not injection molding. I guess I don't see it as moving to the scale of something like injection molding soon. I see it as continuing to provide value in terms of surface finish, the actual material and custom materials, and things like lightweighting, saving time in terms of producing jigs, fixtures, all that sort of stuff. But I don't see it as becoming, something as fast as injection molding. Injection molding, it takes like 1 second to print a plastic, to make a plastic part. 3D printing is a complement to injection molding or a complement to these other processes. I don't see them as, moving to that mass manufacturing soon.
Sure. Yeah.
I actually have a point over here. Not specifically this. It's a question that I'm going to probably ask Mr. Bagre. Mr. Bagre, you're one of the biggest players in the country right now. Is there something where you're thinking about that the supplier fraternity can create a common pool to reduce the initial capex and like a shared service center?
Yeah, this idea is quite long in the industry of EV. So the group of EV suppliers are coming together to form some type of consortium where you can use this shared facility. So this would be definitely helpful. So what has been yesterday from stamping to laser cutting, this will definitely have from injection molding to the 3D printing. So technology always is a disruption. EV technology is going to disrupt further to the all ICE technology. So this kind of new technology which will give value option to the consumer is going to definitely be a disruption in all the walks of life. That's what I would like to submit.
Okay, thanks. Rohit, back to you.
Okay. So yeah, I mean, I've scanned the Q&A section, and a lot of the questions are more on the technical aspect. So I will connect the 4D simulation team and the Markforged team directly with those person. I think soon we can, if you want to do a quick sum up of the session, and then I can
Sure.
maybe do a exit speech after.
Well, thank you,
Yep.
thank you all for joining in, listening in, talking it through. I mean, startups seem to be thinking that there's definitely, thanks to 3D, thanks to all the other technology, there is some disruption up our way. My only point is that everybody was thinking that Tesla is going to be the way forward only. But now when you're starting to see plans of a lot of the traditional OEMs, the Volkswagen Group, BMW, Daimler, there seems to be a big fight back coming that way as well. So it'll be an interesting time frame to see in the next 5 to 7 years which way this directionally goes to a certain extent. Other than that, I mean, I'm a big fan of 3D printing. I'm a big fan of any kind of incremental technology benefit. I'm pretty sure it's here to say. I've seen applications of it wherein you don't need to hold spare parts at any dealer site. Spare parts get manufactured while the car is waiting for other products. And this was something I saw in the US at a big dealer site where they were using big 3D printers for stuff like that. So I actually believe in concepts like these to take the industry forward, irrespective of what it being only for EVs or even for traditional ICE engines. But it will definitely help the EV ecosystem grow and grow fast.
Okay,
So
great.
those would be my 2 cents.
Okay, great. Thank you all for joining us for today's live session on 3D printing, additive manufacturing, and emergence of India as a EV hub. I hope you enjoyed this session and found it useful. Firstly, I would like to thank our speaker group for taking out the time for their incredibly busy schedule for this. I really appreciate your support and you taking out the time. Secondly, I would like to thank our audience for their inquisitiveness and their attention. I mean, we have received well over 40 questions. Some of them more technical in nature, so I didn't want to address it in the larger group. So what I'll do is I'll connect you guys directly with the 4DS team and Mark Foch team, and they will definitely get back to you on all those subjects. And finally, I wanted to take this time to especially thank our partner 4D Simulations for supporting the session. Thank you all for joining us for this session. We have many more on the way. Topics such as lightweighting in EV, ADAS are coming up next, so do join us for the same. In the meantime, a very happy Holi from us and a goodbye from all of us here at TWF and CBF. Thank you so much.